Righty, everyone. Thank you so much for joining. I'm going to go ahead and get started. Welcome to our May webinar, Why RAG Breaks at Scale, specifically talking about the data pipeline problem. So I'm going to kick us off. I'm Julia Martins. I work on the product go-to-market team here at Anyscale. And then Kunling is our LLM and Gen AI expert architect. He's going to be going through an actual demo once we kind of level set a little bit. So really excited for this webinar for you guys today. A few things that we're going to cover. I'm going to just start with like a lay of the land, like why RAG, why is it hard? What are the kind of different steps in the pipeline? What are the different requirements of each step? And then, like I said, we'll go into a demo with Kunling. So really quick level setting, just like let's start with what is RAG. So RAG, of course, stands for Retrieval Augmented Generation. It's a way to supplement LLM models by giving them access to external knowledge. Despite the impressive capabilities that they have, LLMs have like one fundamental limitation, and that is that they don't know your business, right? They haven't read your product documentation. They don't understand your internal processes. They can't access your customer insights. And this creates a critical knowledge gap that limits the utility for a lot of enterprise applications. And we don't really want to train LLMs on this type of knowledge because it's usually proprietary data. So that's where RAG can provide tremendous value. It's an architectural pattern at its core that connects LLMs to your knowledge repositories and gives you the ability to retrieve relevant documents at query time to inform more of a broader LLM's kind of response. So we're going to cover the how of RAG in a lot more detail later, but at a high level, the architecture consists of a few key components working in concert. First, you have to process the actual documents that you want, the LLM to be able to access, chunking it to manageable pieces, convert it to vector embeddings, and then capture their semantic meaning. This needs to be stored in a vector database that's optimized for a type of search. And then when the query arrives, you need to be able to retrieve the most relevant chunks from this vector database and incorporate it into the prompt sent to the LLM. So that's kind of just the overall process of what RAG does. Why RAG? So RAG has several key benefits. In addition, like I said, to being able to access your proprietary knowledge, it's also a way to reduce LLM hallucination. So when you use a RAG prompt, if you do a little bit of prompt engineering, you can ask it to cite specific resources and to really only pull information that it like knows for sure. And then the final benefit is your knowledge base can be continuously updated without you actually touching the LLM model, which gives you the ability to kind of iterate faster. Oh, why isn't this going to the next slide? There we go. The most common alternative to RAG that I've heard people talk about a lot is fine-tuning, which is, again, of course, another way to improve LLM models. And there's a reason why you'd use one versus the other. So you'd fine-tune an LLM model if you had a large knowledge base that was going to be very static and it's not proprietary information. And you want to train the model on it, and you want to be able to use kind of like a model trained on that information. Versus RAG, it's proprietary information that's changing more. You want to be able to iterate more, and that just gives you a more dynamic solution. It's also, depending on how you run the compute, it can be easier that way. So we'll talk more about that later. Why is my slide not working? So we're going to go over some common RAG implementation pipelines, but at their core, all RAG pipelines consist of two main steps. The first step is, like I mentioned, ingesting the documents and indexing them. So because RAG is a way fundamentally to supplement LLMs with external knowledge, all the processes need to start with a really solid data pipeline. Ingesting your documents from various sources, chunking them intelligently, transforming the text into vector embeddings, and then storing it in a vector database. Later in our demo, Kinling is going to walk through in detail the typical data pipeline process and share some optimization techniques to make that better. But generally, the preparation phase is consistent regardless of which RAG framework you actually implement. And then the interactive Q&A phase varies significantly depending on your goals. So the most straightforward type of RAG is called naive or basic RAG. It's just a query retrieve response flow. A user submits a query, the system retrieves relevant documents, and then those documents are injected into the prompt alongside with the LLM response, and the user receives a response. That is kind of like at its core stage, just like what a RAG pipeline can do to augment your LLMs. There are more complicated models depending on your needs. So there's a model called retrieve and re-rank. We're going to go through two of the more common ones. Retrieve and re-rank models build on the basic / naive rank RAG model, sorry, by adding a crucial kind of second evaluation phase, which not only is the information retrieved, but then it will be re-ranked based on kind of precision and quality before emitting a response. So typically this gives you slightly more nuanced answers. And then the third one that we're going to cover right now is there's also a way to do RAG with hybrid search, which combines two different retrieval methodologies in parallel pathways, merging semantic search with keyword-based search. This is really useful because semantic search is great at understanding the meaning behind queries, capturing kind of concepts and broader things that specific keywords can't always do. And then by combining the two intelligently, you can get a more robust retrieval system that addresses the weakness of each individual method. This approach is particularly valuable when your knowledge base contains diverse content, and when your users might be using, like, not, instead of using precise terminology, using more conversational language. But again, taking a step back, at their core, all of the RAG pipelines have two fundamental stages. The stage one is the data pipeline ingestion stage, and stage two is the query stage. And these two stages have fundamentally different requirements and characteristics. And it's really important to understand the nuances of both when you are building your RAG pipeline. So let's talk about stage one, where you prepare the data. At the indexing stage, you're dealing typically with a lot of unstructured files. Remember, this is typically a way, RAG is typically a way to incorporate your kind of like proprietary knowledge. So it'll be PDFs, documents, web pages, presentations, kind of like think of it as your raw knowledge base. So you need a lot of ways to process unstructured files, unstructured IO for text extraction, LangChain for optimal text, Hugging Face for models, that kind of thing. Computationally, the indexing stage tends to be both CPU and GPU intensive. It's CPU intensive for the data preprocessing tasks and GPU intensive during the embedding generation process. The good news is the latency sensitivity here is pretty low. The work can be batched and preprocessed offline, which makes it pretty more manageable from an infrastructure perspective, but it is usually at a very, very high scale. And so you do need to think about throughput. And then when we look at the query stage, it's basically in a lot of ways the exact opposite needs of the indexing stage. So the biggest change, as you can imagine, the query stage, there's a user on the end. And so the latency needs to be really low. They're expecting, very fast responses. The throughput typically isn't as intense. And it, again, is GPU and CPU intensive, a little bit skewed more towards the GPU side. So understanding these differences as scaling considerations shift is critical because they influence how we should architect RAG systems. The indexing pipeline can be designed for things like batch processing with cost optimization, and then the query pipeline needs kind of careful attention to performance and user experience. So the separation of concerns allows us to optimize each stage independently and deploy appropriate resources when they're most needed. And the distinction becomes particularly important when we discuss Anyscale in the next slide. Let's go to that. Sorry about my slides, you guys. I hope they're showing on your end too. Okay. So far, we've broken down the two stages of the RAG pipeline, indexing and querying, and looked at the technical challenges of each. High throughput data processing, embedding large documents, low latency generation, complex orchestration, the need to scale effectively under load, etc. But the question we are here to answer today is, how do you actually build a good RAG system that handles all of that and still performs in production? And that's where Ray and Anyscale come in. So Ray, if you aren't familiar, is an open source distributed computing framework that makes it easy to scale Python and AI workloads across multiple machines for things like data processing, model training, real-time inference, batch, etc. Anyscale is the managed platform built on top of Ray, which gives you all of the power of Ray with zero infrastructure setup. So you can focus on building applications rather than managing distributed systems. And there's benefits to each when it comes to RAG. So Ray gives you the ability to run several key elements of the RAG pipeline, including distributed Python access across nodes, running heterogeneous compute, also known as hybrid compute, basically CPU and GPU clusters, and then having a persistent object store so you don't have to continuously read and write to external data sources. And while Ray gives you the fundamental building blocks for building an effective RAG pipeline, Anyscale helps you take it to the next level. With Ray on Anyscale, you can build, test, and deploy AI workloads in one place. You can eliminate operational complexity with elastic, responsive, and resilient clusters in your cloud of choice. You can run parallel text extraction, chunking, and embedding jobs that automatically scale across both CPU and GPU resources. And Anyscale will take care of things like provisioning, load balancing, failure recovery, governance controls, etc. So if you think about how to actually run RAG at scale with real workloads, real latency constraints, and real cost considerations, Ray and Anyscale give you the platform to do it. To show you how that works in practice, I'm very excited to hand things over to Kunling for a live demonstration. He's going to walk you through an implementation of a basic RAG pipeline and then show you how Ray and Anyscale can help you optimize each component for better performance, reliability, and scalability. You'll see firsthand in real time how the concept we've discussed come together in working code, and you'll leave with practical insights and free technical notebooks that you can apply to your own RAG projects. Kunling, over to you for the demo.
Awesome. Thank you so much, Julia. Before I show the demo, I want to highlight some of the main bottleneck when I build this RAG pipeline. The main issue is how do you ingest the data in a scalable way? Because we know enterprise data 80 to 90% of them are unstructured documents. So in this demo, we are showing to inject 100 unstructured documents, including multiple formats such as PDF, PowerPoint, and HTML. Some of the documents are scanned documents. That's why you need OCR. In this pipeline, we use unstructured I/O, which can do the tesseract OCR extraction automatically. To show the scalability, those documents, they have over 6,000 pages, and one of the larger documents has over 900 pages. For processing entire pipeline from raw documents to store the vectors in the ChromaDB, it only takes about 10 minutes with minimal resources. We are only using one CPU node and also A10G GPU nodes. The total cost is only 23 cents, which is really low. If you run like 6,000 pages OCR using AWS TextDirect alone, that will cost $9. Not to mention the other compute costs you have to put on this. And using other pipeline like Airflow will extremely slow. So essentially you are paying more for those compute costs. And as we can see, Ray data, they support heterogeneous cluster. You can specify on each step how many CPU resources you want to use, how many GPU resources you want to use, and then you can optimize that. For example, if you have a much larger text chunk and then you find out the embedding is the bottleneck, you can easily assign more GPU nodes to processing those. Right, and after everything was finished, then all the compute resources will automatically shut down. So you don't have to worry about the provisioning of those resources. Many customers, they saw over provisioning or under provisioning that will cause either compute resource waste or long running time. By the way, for the demo purpose, we only process 100 documents, but this pipeline, they can scale in a much larger volume. We tested with hundreds of thousands of pages documents. They run very smoothly without any problem. And also, you can easily add additional processing steps in the pipeline. For example, you can use custom deep learning OCR model using GPU node, and you can also plug into, for example, large language model for batch processing to extract, for example, entity or some meta information. So if you're interested, please reach out to us. We can help you to optimize or build your customized pipeline. Okay, next slide. A few weeks ago, we announced a new LLM API. It's an open source library where you can easily deploy or serve the LLM model. So you can do scalable online serving with your own large language model. Compared to commonly used engines such as VLLM, Reserve LLM enables auto-scaling, load balancing, and multi-LoRa model deployment. And also, it's OpenAI API compatible. If you are using, for example, GPT-4o, you can easily switch to the open source model using the large language model APIs. And using Reserve is very Pythonic, very easy to write complex multi-model deployment pipelines. In addition to Reserve LLM, we are also releasing the Ray Data LLM for batch inferencing. So it can fuse seamlessly with the existing Ray data pipeline. I will work through some example later. And one of the key benefits of using batch inference is that you don't have to set up another service just to test or evaluate your RAG pipeline or LLM quality. So for example, you can assign some GPU compute resource for batch inferencing. After that, after the task was finished, then all the GPU node will automatically shut down. You don't have to worry about the maintenance of those services or, some data centers, they may forget to shut down the GPU. That will cause, additional charges. And on any scale, you can reduce the cost further with the spot instances, especially if you are using the batch inference pipeline. As Julia mentioned, it's less sensitive to the latency. With these two new powerful API, we are going to enable our RAG pipeline to make it highly scalable and production ready. Yeah, so now let me share my screen so we can work through the actual code. By the way, you can access code with the QR code here, and also we put the links. And after that, we're going to put in the GitHub so everybody can access that. But right now, it's only on Anyscale. Just to be mindful, because we have several hundred people here, it's better to not run this at the same time. And yeah, we can spread over the day. And later on, if you are interested, you can run on our platform. Okay, let me share my screen.
Really quick, for everyone who's attending, we are gonna be sharing out this recording and this deck, as well as the link to these templates that Kunling is about to demo, via email. So if you don't want to type this in, you will get it shortly.
Okay, thanks. All right. Let me see. Can you guys see my screen? Okay, awesome. So in this tutorial, we actually have 7 notebooks. I know it's a lot. Actually, I want to write more, but for the demo purpose, we want to keep it simple and easy. In the first tutorial, we're actually showing a very traditional regular RAG document ingestion pipeline. There are no Ray required. This is for some people who are interested in RAG but have not able to build the RAG pipeline themselves. As Julia mentioned, it just consists of several common steps such as loading the documents with unstruct IO, extract the document text, and the chunking, and generate embedding, and store the embedding in the ChromaDB. By the way, the embedding model we're using is an open source model as well, but feel free to change the other embedding model you are interested. The second notebook will make the previous RAG data ingestion pipeline scalable using Ray data. As we can see, we can leverage any scale compute resource to make it highly scalable. To show how it works, first we will load some data from the AWS S3, and those are the raw documents. And after that, you can do the document extraction and the pagination using Ray data. And here we are using the map in the read data to process in those documents with the function we defined here. As you can see, we also extract not only extract the page text, but also the page number, because later on when we use RAG to generate answers with citation, you want to know which page number the answer coming from. And we can assign the CPU or GPU resources and also the concurrency, how many processes we want to run simultaneously. And on the other side, actually, you can see what kind of worker node or CPU resources you are going to use. And this will spin up automatically based on those parameters you set here. And after that, we can define our own chunking function. Here we are using line chain to split the text chunk, but feel free to write your own text chunks. And after that, we are building the embedding model. And here we are using the Hugging Face to download the multilingual E5 large instruct. This is one of the top open source embedding model. And here we are actually using GPU to use the embedding model for batch processing. And after that, we will write the data, vector data to ChromaDB with this custom function. And after we define all those classes, we are able to build the processing pipeline using read data by connecting all the steps. And as you can see, you can specify the resources you want to use, how many processes you want to run, and also what are the compute resources. So this is very customizable based on your own workloads and highly scalable if you want to run a much larger volume. And in the end, we will do a quick test to make sure the document ingestion is successful. For example, you can ask a question like how to submit jobs on Anyscale. As you can see, the retrieved text chunk are very relevant. That indicate the success of the text ingestion pipeline. In the next tutorial, we will show you how to deploy large language model using our new Reserve LLM API. Most of the code are very easy to follow. Basically, you just to specify the model ID and also underlying we are using VLLM. And you can specify the parameter for those. And also you can specify what kind of GPU you want to use. And after that, you can start to calling the model using OpenAI compatible API. And here we are able to show it can generate answer either using streaming mode or you can generate answer in non-streaming mode. We support both. Okay, so next one, we're actually going to build the query part of the RAG application, which Julia mentioned earlier. So for the query part, first we have to convert the user request into embedding, and then using our vector database to find the relevant text chunks. And also we will have a prompt template to render those prompts based on user requests and retrieve the context. And after that, we send to the LLM service we just set up before and get the final response from RAG. So this is also pretty straightforward. Yeah, you guys feel free to work through this. But I want to point out in this tutorial, the RAG response is very simple. And as you can see, we are asking how to submit Anyscale jobs or what is Anyscale job. It just give you a very simple response. You don't know if this answer coming from the large language model itself, right, or it coming from the text chunks you retrieved, right? So the reason is that we are actually using the prompt template from LangChain tutorial, which in this number 5 notebook, we are going to show you how to improve RAG with prompt engineering. This is a very common problem. A lot of people find tutorial online, they follow the steps, but the RAG chatbots that they build, the quality seem not to very up to standard, right? So in this tutorial, we are going to show you how to improve the RAG prompt. So in the previous notebook, the prompt we're using is actually coming from the line chain. And this is how the prompt look like. You have the user request, you have the context and the retrieve the text chunks. However, it has this, many issues. The response quality is only one issue. For example, it can expose the identity of the LLM model you're using, right? Or it cannot deflect the irrelevant user requests. Some customer or some people, they will do the hacking or prompt injection, or even use your chatbot to do other things you don't want them to do. So you need a proper deflection for the irrelevant user requests. But with this simple RAG prompt, you are not going to do that. Um, in this tutorial, I'm proposing an advanced prompt that handle all the problem I mentioned before, but also it provides additional features. For example, it's domain specific and it's context aware. It will check the relevancy of the retrieved text, and also have the default fallback strategy. And also it has maintained the language consistency with the user request. Feel free to read through the prompt and also check out how the quality has been improved compared to the basic prompt. So here we can already see the user asking what is Anyscale job. We already see massive improvement in the responses, right, compared to the previous demo. The other common question people asking, how do you add enable chat history for RAG? Because if you want to deploy RAG as a chatbot, you want to support multiple turn of the conversation. Of course, you can add a chat history session in the prompt and send in those chat history. And in most of the cases, it will be working fine. But in some scenario, one of the key problem is that during the follow-up question, the user will not mention the full context of the question, right? So in that case, you have to derive the full context based on the entire chat history. That's why here I'm showing you how to transform the current user request based on the chat history to give a more complete user query. And that user query will used in the next step to find a more relevant text chunk. So this is one example. The current user request is, are there any prerequisites or specific configuration needed? Using this user request, if you do the semantic search on the ChromaDB, find the vector, you are not gonna get any, right? Because all the content actually coming from the chat history. Using this module, which is also based on the large language model, you are able to transform the previous user request into this more complete query that can use to retrieve relevant text chunks, and then you are able to get a good answer. So this is how we enable the chat history for RAG. And the other common question people asking, right, I saw, OpenAI chatbots, they are able to generate the citation, how we can enable that when we're building our own RAG So this is a tutorial for that. Basically, you have to generate a very special citation format. And then after that, you can use regular expression to substitute those special token with your actual links. Yeah, feel free to check the details of the code, and I will show you the final responses it look like. So here is the final responses after we made this improvement, right? So the user question is like how to delete or terminate the job on Anyscale, this is the chatbot responses. You can see it has a really good formatting. It has the clickable citations, and also it shows the page number where the document coming from. So compared to previous demo we show using the line chain RAG, this is the quality of this RAG bot has been improved massively. Yeah, so there are a lot of like more things you can do RAG to make it even better. But for the for this demo purpose, we will just show you the key aspect to improving the RAG. The next tutorial is to evaluate RAG with online inference. We all know after you build in the RAG bot, you have to evaluate from different categories of the user requests. Here we provide some evaluation data. It only has like 64, but feel free to add your own or more data sets. As I mentioned, for each category, we have to assess RAG quality. So in this data set, we'll assemble some common question like the identity, for example, the harmful request, as well as the domain-specific question. And using this online inference, you can get the responses from the RAG for each of the question. However, this pipeline is not scalable, right? Because it's using the online inference. For example, you have a LLM service deploying your system. If you evaluate RAG using your LLM service, which is also using production, you are going to disrupt the production services. And if you are using OpenAI, then usually they have a certain quota limit. You don't want to jeopardize that. But if you want to deploy a separate service for evaluating RAG, as you can see, you need DevOps people, ML ops people to set up the entire pipeline and maintain them, which is a lot of additional work to do. That's why we're introducing the batch inference evaluation pipeline using the Ray data LLM. So for example, we are loading the evaluation data set from the CSV file, and then we can processing this data using just a CPU worker nodes to convert each of the requests into embedding and using ChromaDB to get retrieve the context. And after that, we can render the prompt using the advanced prompt template I proposed. And once we got the final render prompts, we can call the Ray data LLM API and using the batch processor. And we can assign the GPU type or how many GPU to use to run this pipeline. And after that, we will get the responses for each of the requests in this evaluation data set. And after that, you can either manually check the quality, or you can use another more advanced LLM, especially the reasoning model. And that will help you to build your own golden data set for automatic evaluation in the future. Yeah, so this pipeline is super flexible and powerful. You can apply the similar pipeline in the pre-processing as well, as we mentioned, not just in the evaluation. For example, you want to use the large language model to extract the metadata from the raw documents. You can actually go back to the number 2 steps and modify the code there and building your own batch processor. So as I said, this process is highly adaptable, and we are integrating with the Ray data pipeline seamlessly, and in order to save the computer resources and also make it easy for you to run a batch jobs. Okay, that's all for the notebook. Yeah, so Julia, get back to you.
Sure. So yeah, quick kind of final summary before we have plenty of time for Q&A, which I'm very excited about. So in summary, these notebooks that Kunling shared are actually all available for you to try for free on Anyscale. If you start today, you also get $100 in free credits where you can actually like test and deploy them. So use this QR code or go to anyscale.com. If you're interested in a more in-depth demo, feel free to book a demo with our sales team, or if you just want to connect with other practitioners who are, using Ray, talking about distributed training, doing RAG, all that kind of stuff, join our Slack channel. Slack community. Sorry, it's not a channel. And as I mentioned before, we're going to be sharing an email with this recording, this deck, and all of the links that we mentioned. It'll probably go out tomorrow or the day afterwards, so stay tuned for that. And yeah, we're super excited for Q&A. So I'm also going to bring on Goku, who's on our product team, to help us answer questions. Goku has actually already been answering a lot of questions while Kunling was doing his demo. So I'm going to bring Goku on and have him answer some of those live because they were really good questions and we want to make sure everyone hears the answers to them. So Goku, I don't know if can you add your video? Can we see your beautiful face? Are you there?
Hey guys.
Hi.
Hey,
Okay, I'm just gonna
I've been
reiterate some of
answering
the
these,
questions
yeah.
that you've already answered,
Yeah.
just so that people can hear them out loud. What do we have? So someone asked, which factors, apart from company policy and compliance, do we need to consider when choosing a vector DB for a project?
Yes. Okay. So I answered most of these. I think there's only two questions left. We can go through them all one by one, or I can just give a summary if I gave more details in the response, but there's a lot of other things you want to consider. Feel free to add more, but I think my kind of high level ordered list is you want to look at what performance scalability looks like for your specific use case. So if a lot of them have open source uh, kind of variants, play with those first. And then a lot of them do have proprietary runtimes. So then go ahead and try the enterprise versions and see how they fare. They all should have trials. So after that, then you want to look at things like, how well can this scale, especially if my workloads are much larger. Can it scale horizontally? Can it support the data formats and volumes that I may have? Um, then, as Kunling mentioned as well, you also want to look at the different capabilities. They're all kind of playing this cat and mouse game of kind of catching up and having similar functionality, which is great. But if you are relying on more complicated or performant querying features, hybrid filtering, etc., you want to make sure it has those table stakes things. And then maybe just as important, you want to make sure it actually integrates with the rest of your stack, right? You shouldn't have to break apart how you've already built the rest of your pipelines. And you want to make sure you're choosing something that doesn't force vendor lock-in because that can get very expensive. So yeah, these are just some of the things. There's a long list of other things, observability, security, but yeah, these are maybe the top of mind for developers.
Awesome. I'm just going to go through some more of the answered questions. While we do that, please submit any questions that you have through the Q&A feature, and we'll be going through them as well. So another question was, we'll use AWS S3 and Lambda to store embeddings in OpenSearch. Can you please, what are the advantages of using Ray? Like, why should we consider doing that?
Yeah, this one, I started writing a list and I stopped because there's a lot of reasons. Um, and I think maybe in a month or so, we'll have a webinar of around like why it's really useful to use Ray across your data workloads like batch inference, ingestion for prior to training, stuff like that, or even just structured data processing, as well as for training large models or small models, or many small models, and obviously serving all of this logic. So we'll go deep into all these, but specifically for this, because they're storing data somewhere, and I'm guessing they want to do some kind of data processing or batch inference workload. Keep your data where it is. You don't have to change that. There's no lock in there. And we have somebody else asked the question about, can I use Ray like data connectors and to support multiple formats? We support all of the kind of well adopted ones, but you can also easily use native Ray to build on top of your own formats. But I'll just cover like a few things. So once you load your data, first of all, actually even loading your data, imagine like you have a very large data set. You should not have to provision your compute to fit that whole thing in memory, right? It's going to be extremely wasteful. So ingestion is already streaming by default, which means you can load exactly what's going to be processed for that batch or a few batches and not have to wait for the entire data set to load or choose your compute based on the size of your data, which is extremely wasteful. We make it extremely easy to chain different kind of workloads. So you may have CPU processing like you're filtering on some images or you're creating patches, but the very next part of that pipeline might be a GPU focus, like generating embeddings, using a model, a very large model. So all of this can be written in Python, and you can chain this just like you're writing, two different functions with NumPy or pandas and putting them together. So for a developer, that doesn't change much, but you're actually doing pretty complicated workloads on different types of machines all in one view. And maybe just like one more I'll cover that I wrote is maybe like actually taking this to production. You can serve Ray yourself, or you can use Anyscale with whatever cloud provider you're on, right now. Or we also recently create a Kubernetes operator. So to actually take your workload that you're developing, and you have great observability tools as well to get into production is actually pretty easy, because when you're developing on a large cluster, you're already developing in that multi-node scenario. So there's not much of an environment change when going to production. And we support kind of batch jobs and online services and a lot of other components as well.
Kunling, anything to add?
Yes, I saw a lot of people asking about the embedding DB, so I want to add a few more things. Yeah, we are using Chroma DB just for the demo purpose, and Chroma DB, in my opinion, has really good user experiences. However, the scalability, the performance may be a little slightly, worse compared to other commonly used vector DB such as Viviet or even Pancone. However, Pancone is only like has a proprietary solution. You have to use their cloud version. And if you look at the price model, if you have a large volume of data set, it's going to be super expensive. Viviet, on the other side, have two versions. They have open source version as well as the enterprise cloud version. You can choose to deploy using Viviet. And compared to Pancone, Viviet also supports, for example, the hybrid search mode. You can search with embedding using semantic search, but also they allow you to search using regular text search. Chroma also support some text search feature, but it's relatively simple. And also some people are using Milvus, which is the older vector DB library. And from my personal experiences, Milvus a little bit harder to use. Yeah, so based on your preference, or if you have like no develop people to set up, I think you can use Bancon, right? But you have a really big engineering develop team, setting up your own vector database seem to be a more affordable way. Yeah.
Sweet.
Awesome. There's one more question, or actually there's a lot more questions, but one I was just answering, but I'll just answer live. Someone asked, can you use Ray for fine-tuning LLMs? So for RAG, you probably should experiment without fine-tuning things first, but if you need to fine-tune for your use case, we have a couple different ways within Ray that you can do this. So even before, 2 years ago, when people started fine-tuning LLMs, there was already a lot of open source code out there. People were using Ray with something like FSTP and Hugging Face Accelerate to kind of stitch together to be able to tune any kind of torch or transformer-based models. Since then, there are a lot of other open source libraries out there that offer fine-tuning. Axolotl, there's a few others as well. Basically, what we've done is enable a Ray train flag where you can use the same code that you do with those open source libraries, but now you can run it in a multi-node setting. So with Axolotl, it's as easy as just passing the Ray train equals 1 and then passing in your compute config that you want to scale it out to, and it works. Something that we recently launched, I'll just paste a link to that question. There's many flavors of post-training, right? Supervised fine-tuning is just one. There's different RL-based methods, TPO, PPO. There's even more coming. You're gonna see a lot more in the next 6 months. But we've been working with the Berkeley teams specifically to release some open source packages. I just pasted a link there if you're doing some of the more sophisticated flavors of post-training.
Yeah, for fine tuning on Anyscale, you can actually use the Llama Factory for fine tuning. We have another tutorial, and also if you sign up on Anyscale, you will find a notebook to show you how to do the fine tuning. As Goku mentioned, we support supervised fine tuning, but also we support more advanced fine tuning technique, such as DPO, or KTO. Those are most recent fine-tuning techniques. We also support older techniques such as use reward modeling plus PPO. And I do think if you are interested in fine-tuning, in my personal opinion, fine-tuning might be a little bit more adjustable if you have a very specific format of your data. For example, some of the large language model may have a weird JSON format when they generate a JSON, or you want to improve the quality on that, or you have several steps in the large language model, right? And also the quality is not great, then you want to use fine-tuning to generate the appropriate answer. Yeah, so there are a lot of fine-tuning use cases. The other use case is to actually collect more data using the agent framework. And after the interaction with the environment and tool calling, you can collect those data where the agent failed or large language model failed. You can fine-tune on that. Yeah, so there are massive use cases for fine-tuning as well. And please feel free to sign up on Anyscale to try our fine-tuning framework.
Awesome. The next question is, do you have any advice on how to measure recall for RAG retrieval at scale?
That's a great question. So I think there is a automatic way you can measure the recall during the ingestion pipeline. So basically, you break the question into break the text into several text chunks, and also you can use the LLM model to generate a relevant question during that stage. Right? So those questions already linked to those text chunks. So later on, when you use that question and then calling the RAG pipeline, you are supposed to find those text chunks. If you are not going to find it, that means there's something wrong in your RAG. And using this approach, you don't have to manually, curate the data set, which is like very time intensive and expensive. So this is one way to measure the recall or retrieval for RAG at scale.
Awesome. Continuing on the kind of scale questions. So while we have many advantages of RAG, what do you see as the key limitations or risks of using RAG in production? For example, in terms of retrieval noise or context overflow or dependency on embedding quality.
That's a great question as well. So personally, when I build the RAG pipeline, the quality of RAG is also affected by few factors. Number one is the user's query is diverse, very diverse. Some of the user query very short. Sometimes the user they copy paste their entire code into the question. So if you are using embedding, you are not able to find a high quality answer, right? So in order to address that problem, you can build for example, intent detection module, or you can transform the user query into more digestible search queries using large language model. In order to reduce the latency, you can choose smaller model for this kind of task, but you have to do some kind of transforming for the user query in order to get a better matching quality. Right, so that's one common problem I'd say. The other common problem is that when you have a lot of documents ingested, and then how to select the threshold for RAG is tricky. The threshold, if it's too low, then you got too many text chunk match. If it's too high, then you got too little text chunks. So in that way, we probably need to build another ranking module or filtering module. There are certain API to do that, or you can build your own supervised filtering module. Coco actually wrote a blog about that. And the other way, you can also use large language model to build a ranking or filtering based on the text and also the user request. Usually for RAG, we choose a larger model in the final responses. However, for this kind of query decomposition, augmentation, or this ranking module, you can use a much smaller large language model like 7B model to do this kind of simple task. And if you are, have more data science resources, you can also fine tuning a large language model for ranking and filtering those answers. That will help, the final stage generation answer quality improved. Yeah, so that's some of the common technique we address the quality of RAG.
Anything to add, Goku? Oh, you're unmuted.
Sorry, I'll just add one more because it's like the crux of what Kunling showed. The reason cost matters, I know some of you had questions about that first slide. That's like one instance, right? And that's on a small data set. So imagine the amount of data you have to index is large, and you also want it to be fresh. That's going to be like a very recurring batch inference workload. So the ability to scale this out and do it in the most like cost-effective, efficient way is going to pan out over time, especially if you are using one of these embedding models or retrieval models that are not made for your domain specifically, but you can't pre-train or you don't want to pre-train. You're going to want to constantly update your index and update these. So yeah, that's why using something like Radata is going to actually come in very handy even in the short run.
Awesome. We have a question. Our RAG chatbot also connects to 2 web UI and our customized auto eval pipeline. If we use Anyscale, how can we connect these 3 components efficiently?
Kunling, I can take the first stab. So someone else had a question about like using different stacks, like the MERN stacks, which is, whatever your custom front end, back end tools are. You could treat all of these as extremely atomic instances, right? So let's just put all of the things around RAG, including like building the index and serving the different models and routers that you have as one application or one topic. That's a service, right? So it's a service that can communicate with anything else. So your UIs can easily communicate with those, add all the tokens that you want on top. And same with your auto eval pipeline, right? So if you have some offline process here that's generating some outputs, you can easily connect that job to whatever your auto eval pipeline looks like. So whenever we explain, when people come and ask like, I'm using this orchestrator to connect all these different tools and UIs, think of all of these array workloads and even the entire application as just nodes in whatever DAG that you're creating. And it's pretty trivial to actually use these wherever you want. And yeah, if you want to break apart that RAG service that you built into separate pieces, you can do that too, because you're probably not going to, or maybe you will, but you're probably not going to index every single time that you're updating, something about your service.
Yeah, to add on that, we also have Anyscale service, for example, to deploy the front end for RAG chatbot. And on the back end, you can use Anyscale jobs. For example, if you want run the data ingestion pipeline every single day, every other day, or every week, you can use the Anyscale job to do the data ingestion pipeline in a periodic time, right? So, and also same as evaluation, you can also create Anyscale job to run the evaluation, connecting to the data sources. So as we all know, Anyscale is highly flexible to do any kind of data engineering, data science, large language model related tasks or jobs.
Awesome. And then we have a question. When assessing performance, does Ray provide any tools to pinpoint exactly where the RAG data pipeline is falling short?
Yeah, so actually we have a lot of the availability tools on Anyscale. You can look at, for example, on each steps, what are the function have been used, how many like tasks have been executed, and also if you on Anyscale we have readable, we also enable the checking point for the Ray data pipeline. For example, if the Ray data pipeline failed, you can easily resume the workloads rather than start from the scratch, which is really powerful feature in this RAG pipeline. And on top of that, you can also leverage the Ray metrics. We have all the Grafana metric dashboard. You can see how many resources are being used, GPU, CPU, and the disk, memory, etc. So using Anyscale bring you a lot of features to provide you the insight if the RAG pipeline is failing or have some have some issue there.
Goku, anything to add?
No, I mean, it nailed it. This is like the issue that we kept hearing over and over for the last couple of years. You have your workload, you're scaling it now. It's across thousands of worker nodes. Just imagine like leading, actually working with all those logs and all the different parts of the stack that can go wrong. So observability is one of the top features that we've added on Ray and then plus plus on Anyscale to be able to quickly dive in and fix these things. And it's not linear, right? Just because you see utilization is low doesn't mean there's one thing you can change. There's like 10 different things that you can change. So the ability to actually know what I can change and then what impact I can have, all the views that Kunling mentioned is going to let you make that decision.
Awesome. And then last question that we'll be able to answer here today. So this person asks, last time I used Ray was a year ago when I built my DRL agent. Can we use it in LLM for RLHF?
I'm not familiar with DRL. As Goku, are you familiar with that term?
Can the person like just extend what's the DRL if they're available still?
I'm not sure.
But for the agent,
Deep reinforcement learning.
oh, deep reinforcement.
Okay. Um, so they already built the RL agent. They want to use it as use it in LLM for RLHF. I mean, I don't see why not. Yeah, I mean, so if you have, so one of the links I shared in the answer when someone was asking about fine tuning is one of our solutions for kind of creating or doing post training with different flavors of RL. So if you've already done that or you want to do reward model training and serving, that's kind of where you want to go. And then you can also do like policy optimization with RLib on top of that. And then after that, you can treat it as kind of, that's the checkpoint of my LLM and the policies that I want to use with it, and just be able to use it as any other model that you want with your RAG pipeline or batch inference pipeline, whatever you want.
Yeah, recently there are so many advancements in RLHF. So originally when ChatGPT was released, it actually called Instructor GPT. They are using the reward modeling plus a PPO method for RLHF. However, that method is very expensive to collect the data and also super hard to train. That's why later on people shift to using DPO, direct preference optimization. And if you use OpenAI, you will see sometimes it will give you two answers, right? You have to click which one you prefer. That actually coming from the DPO data requirement. And recently we have the KTO method. You don't need those two answers, A/B testing answer. You just need the user to give sum up, sum down. You can use that data for RLHF. And as I mentioned, Anyscale with Llama Factory, we support all the fine-tuning method for LLHF. So because there are so many advancements recently, feel free to check out, on Anyscale and also on Llama Factory, how we enable those.
Awesome. So we are at time. Thank you everyone for joining. Like I mentioned, we'll be sharing the templates, the deck, the recording out via email. And if you have any questions, please either book a demo with our sales team or join the Ray Slack channel. Thank you so much and have a great rest of your day.
Thank you.
There you
Bye.
guys.
Bye-bye.